Hello, and welcome to our group project presentation on circuit visualization. So CIRCT is a domain-specific language built on top of a multi-level intermediate representation, or MLIR as you'll hear us call it. CIRCT is designed to encode, well, hardware circuits, similarly to how Babalola does it, but at a more abstract level so that more things can compile down to it and optimizations are agnostic. Currently, to visualize the circuits you have designed, you don't really have the best tooling. You only really have generations like this, as you can see, where we've used where it's used Graphy. This is already in CIRCT currently. Our goal is to send this to Google's AI Model Explorer to try to make a better interface. And to do this, we've split it into 3 steps. Or 2 main steps and then a QA section, where we take MLIR and we convert it to JSON, and then we show the JSON in Model Explorer. Later we also do testing, which we will talk about a bit.
So, quick technical explanation. Model Explorer supports a very specific format of JSON, which we decide to use. And so we add 2 new passes to CIRCT opt, which is the CIRCT pass system. And we add a instance graph pass, and we add a operation graph pass. So we basically receive a parsed MLIR structure, and then we recursively traverse it to collect appropriate information such as maps, modules, and edges, and then we use that to make the appropriate JSON.
Yeah, so as part of the Python adapter, it works as a plugin to Model Explorer, and you can use it and interact with it with the Model Explorer UI and GUI. So it works by first calling the C++ function and then converting the JSON output. It also involves node coloring to show different dialects, etc.
Here you can see some examples of graphs generated by Model Explorer on outputs from our instance and operation graphing passes. So on the top left, you can see an example of a code file written in the hardware and combinatorial dialects. On the right is an example of an operation graph, and on the bottom is an example of an instance graph for a more complicated open source code file.
Yeah, and then in addition to this, we to demonstrate to you guys how we actually tested the product and to just show the product running, we made end-to-end sightless tests. So here you can see them running in the background, traversing the graph, making sure that it is laid out in the way that we expect it from the MLIR. This is done by just programming the browser to follow certain instructions and was relatively straightforward to do compared to the actual implementation.
So the main challenges of this project was building the C++. It was very large. You can see it's 116 gigabytes. We overcame this with time. MLIR and CIRCT don't have the best documentation, so it's quite hard to read and understand. And another challenge we encountered was finding an intuitive way of separating instant graph and module graph generation. So you can see using the UI here, that's how we solved it.
Nice. And in summary, we reached our goal by creating a new form of tooling for CIRCT. And now this is something we can possibly put upstream.